Goedemiddag. I also speak Dutch, but I prepared my presentation in English. It's 2025, almost 2026, and I guess at every board meeting, in every strategic plan for 2026, it is written in capital letters, AI. And for utility network operators, that could mean a lot. It means we want to know when a network will break, and we want it to repair itself. We want to know when a customer will call before they will even call. That's AI gonna do for us. And I'm here with a quite pessimistic message to start. It's not going to work yet, because there's one key ingredient missing, and that is good data. This is what the consultants are selling us. It's about a very nice looking dashboard, and we expect managers to interact with it and ask things like how to connect a new neighborhood. What will happen if there's a cable cut in this area, and how should we repair it? And the dashboards, they will spit out answers flawlessly. And if you ever worked with large language models in the past, you know it can do it with a lot of confidence and give you the answers. But let's take a look at the data behind this dashboard. It's a lot less magical, a lot more human. This is Toko. This is the muddy, chaotic reality. And this is actually where your data comes from. It's not from a clean server room, it's the guys or girls, 2025, in the street. And they have to go to a construction site. They have their plans, they see the cable is on the left, so they move to the right. They take their scoop, put it into the ground, bam, network cut. Network goes out, and he has to repair it. And whatever he or she does needs to be captured. And today it lives in the head of the contractor. Hopefully he scribbles it on pen and paper, and maybe it ends up in your GIS. And if you're lucky, it does that within 6 months. For many operators around the world, there's still a very big time delay between whatever happens on the field and updating that GIS. So what happens if we unleash the power of AI on that type of data? I mean, I don't want to be too pessimistic, but AI, it is not a wizard. It's an amplifier. If your data is fragmented, scattered, outdated, and you train AI on that, on bad data, you will get bad results. Garbage in is garbage out. It has been the rule for over many decades, and it will not change just because someone invented some neural network and called it AI. GIS is... So let's talk about what is a digital twin, a geospatial digital twin. And we've seen very cool presentations. For some industries, a digital twin actually just means a super nice 3D representation. Something that you can look at on the computer and you spin around and it's nice to look at, but that's not all of it. If you study digital twins, it's about modeling reality in order to make better data-driven decisions. That's our goal. And I think one of the key aspects of that is the synchronization between outdoor and the back office. And a typical GIS file is like an image of the past. It is documented what has been done. But you want to have a digital twin acting like a movie on what has happened today. There's a new cable being constructed, a new neighborhood is connected to your network, it needs to be updated now, not after the contractor's holiday. So let's start by describing the different maturity levels of GIS at different organizations. And I think, if I'm honest, most organizations around the world are still in level 1, descriptive. They have a GIS, and everything is documented there, but they also have spreadsheets. They also have PDFs. And not all departments within the organization are using it. It's quite siloed. And so the next step is actually, in order to become a digital twin, it has to be informative. It has to inform all departments at the organization. That means that the data needs to be accurate, complete, and up to date. And that's only possible when we start connecting the different departments around a single source of truth. Next up, we can talk about predictive digital twins or predictive twins, because once we have all that information, we can have also the capture of the historic data, and based on historic data, we can make better predictions. And then we can go maybe to the holy grail that AI is promising us, autonomous, actionable twins, because if you can predict a network outage, if you can predict network congestion, you can have agentic AI working on that to prevent that. My main message of today is, if you are at level 1 and you want to jump to level 4, you will break your neck. So let's do it step by step and go towards that level 2. Let's describe what a digital twin should look like. And for Mercator, we have been helping utility network operators all around the world. And I think it's very important to understand that it's much more than a GIS. If it was just about buying a new GIS and all your problems would be solved, I think Steph, Christian, and the whole GISsat team would be retired. It is not just about the GIS. For us, we needed a network inventory model to model the whole network, of course. It's quite complex, the data model. Sometimes I think you have to have a PhD in physics to understand that data model, but we need it to describe how, in our case, fibers are connected. It's about a route, and in the route there's a duct, there's cables, there's fibers, and then you have a splice closure, and there's thousands of splice connections, and you have to manage that. That's the complexity that Marlin DT can cover. But there's other building blocks in the organizations that we need. And one of them that's actually also very crucial is address management. It's not about your network inventory that you just should throw an Excel file with new address points that need to be connected. You have the need for a separate address management solution that helps you transform from a house to an apartment and manages the complexity and generate what we would call a demand point. And that demand point is actually quite crucial because it will align the network inventory, but also the whole OSS and BSS stack behind it. And it can even be used to report, for example, to regulatory instances. Next to that, a document management system. Of course, you can just add pictures and everything in your GIS, but sometimes when you want to document the full life cycle from planning, design, construction, and so on, you have permits, you have survey data that needs to be stored somewhere, and it needs to be accessible to many departments out there as well. And then, of course, your GIS. Super crucial, but it's not the only thing. And every asset would be stored in Marlin DT, for example, but addresses, buildings, consumers, they would be documented in your address management, and the GIS tools will help you expose that data to other departments. And project management, also important, because a life cycle of a network is complex. It is continuously evolving, and you have to manage it step by step. It's useful for forecasting, for budgeting purposes, and so forth. But then, we need something else. We need actually to unlock the data within these applications and bring it to something much more easy to understand. We call it Marlin DT Network Intelligence, and it's exposing the data from all these different foundational building blocks, but make it flat, make it consistent, make it continuously up to date as well. And this is a data where you can build intelligence for the whole organization. And this is actually also the data that could be used to integrate the OSS, the BSS, integrate with other applications, and essentially also will help you on that AI readiness. So now maybe your next question might be, okay, we don't need only a GIS. What tool do I need to buy? And also there I have to disappoint you. Out of the box, it just doesn't exist. It's quite complex for utility network operators. You have different building blocks that need to be connected. And we call it the data integration layer to connect the different tools to make sure that data flows from one tool to the other and make sure you have it available in your data warehouse. It's a team that builds those workflows, maintains those workflows, and ensures quality of your data throughout all these applications. So now we have foundational building blocks. I would call them the bricks. You would have that data integration layer, which I would call the cement, to hold it all together. But then we need an extra step, the processes. And these processes are there for each and every organization. It starts always with a survey. It's the preparation for planning and design. You need to know what's there. And when you're surveying a building, you want to take a picture, see how many floors, how many units, and you would like to update the address management automatically. If it's about surveying existing networking assets, poles for example, you want it to be connected as well. But also information on the underground, for example, the road surface types could be stored in your GIS. And once you have everything surveyed, you can improve your planning and your design. They know what's available, they know what to take into account to make the right construction plans. And here, it's also essential to bring those construction plans to the field. Of course, also on pen and paper. Also in Belgium, we still use it. It is reliable. It doesn't run out of battery. But you also need the field enabled to update that information back to the office. And then you have very powerful data that will help the operational side of your network. They know what's out there, they know how it is connected, and they will become more efficient. And then the whole business. Steph talked in the beginning on building those dashboards for management, for the C-level, to understand what's happening, where they need to invest more, and those are use cases as well. How does it look like? Bringing it to the field, I think an important message is the field is always right. It's not entirely correct, but what they build needs to be documented exactly like they build it. It might be built incorrectly, but you need to know it. You need to give them the tools so they can adjust what they have built, take a picture, and send it to the back office. So it updates your digital twin in real time. And what will happen then? Well, even without unleashing the power of AI, there's already a lot of benefits. If something goes wrong in your network, you have an outage, your customers calls, you know where the network fault is, you know which technician to send, with what material in his truck. So with a single truck roll, with the first time right approach, you will save a lot of time. So the time to repair will decrease. You will have less truck rolls, you will saving a lot on the operational expenses for the network operator. And then, finally, then we can start dreaming about AI. And then we can start dreaming about AI. And what are the different use cases of AI? I wanted to show it on this slide. Apparently something went wrong. But on the survey, I think the AI use cases are fantastic. Taking a picture of a building, understanding what they see, like shown by Christian and the team, it's fantastic. But the same is true if you take a picture of a cabinet or a splice closure and how it has been built. AI is able to read what has happened, what has been constructed, compare it to your designs, and then update the network inventory automatically. That's as-built data capture with AI enabled. In planning and design, I don't see too many AI use cases because it's heuristics, it's software. You need to have very accurate designs and that need to be trustworthy in a way. But on that operational side, there you can unleash the power of AI. So, main message of today from my side is start with the foundation. You have your GIS, you have your network inventory, you have those building blocks. Integrate them and make sure everybody is connected so you can inform the whole organization about your network. And actually, if you start doing that, it's not only about building a better network, at the same time, you're also building a better organization that is ready to embrace the future of AI. Thank you.